Welcome to the session on exponentials and logarithms, working with natural logarithms. The objectives for this session are to describe and use the natural logarithm function. Exponential functions, recall, are functions of the form f of x equals a to the power x, where a is a constant. The differential is f dash of x equals k times a to the power x, for k a constant. As a increases, k also increases. You will recall that we sketched graphs of f of x equals a to the power of x for various values of a and their corresponding differential function. Remember, this was y equals 2 to the power x and its derivative. This was y equals 3 to the power x and its derivative. And this was y equals 4 to the power x and its derivative. Remember that there exists a value e such that f of x equals e to the power x equals f dash of x, as shown in this diagram here. Recall that the exponential relationship a to the power x equals n can be written in terms of a logarithm, log n base a equals x. And of course, as we said in the last slide, there exists a value e such that f of x equals e to the power x equals f dash of x. The graph of y equals the natural log of x, which equals log x base e, is a reflection of the graph y equals e to the power x in the line y equals x. So here's y equals e to the power x. And here's the line y equals x. Let's now take a look at the natural log. How does this look in our graph? The natural log, as we said earlier, is a reflection in the line y equals x of the graph y equals e to the power x, as we can see here. So the graph of the natural log passes through 1, 0 and does not cross the y-axis. And also note that the natural log is only defined for x greater than 0. Notice in the graph of the natural log, we begin with a rapid increase and then a slow increase. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1 part A first. We are required to solve 2e to the power x equals 7 and give our answer in exact form. So let's solve this. 2e to the power x equals 7 implies e to the power x equals 7 divided by 2. Of course, we've simply divided by 2 here. And therefore, e to the power x equals 3.5. So if we take natural logs of both sides, so ln of e to the x equals ln 3.5. Now, since the natural log is the inverse of e, we have x equals the natural log of e to the power x. And therefore, x is equal to the natural log of 3.5. Now let's have a go at example 1b. We are required to solve the natural log of x equals 80. So let's solve this. When the natural log of x equals 80, we have e to the power ln of x equals e to the power 80. Since e is the inverse of the natural log, we have x equals e to the power ln of x. So therefore, x equals e to the power 80. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2 part A first. We are required to solve e to the power 5x plus 2 equals 8 and give our answer in exact form. So let's solve this. Now e to the power 5x plus 2 equals 8, when taking natural logs, gives us ln of e to the power 5x plus 2 equals ln of 8. And of course, since the natural log is the inverse of e, we have 5x plus 2 equals ln of 8. And rearranging gives us 5x equals the natural log of 8 minus 2. And finally, dividing through by 5 gives 1 over 5 times ln of 8 minus 2 equals x. Now let's have a go at example 2b. We are required to solve 8 ln of x plus 2 equals 9. So let's solve this. Now 8 ln of x plus 2 equals 9 implies, once tidying up, 8 ln of x equals 7. Of course, we've simply subtracted 2 from both sides. And therefore, dividing through by 8 gives us that ln of x equals 7 over 8. Now raising both these sides to the power e gives e to the power ln of x equals e to the power 7 over 8. As before, since the natural log is the inverse of e, we have x equals e to the power 7 over 8. And now for 2 part C. We are required to solve e to the power 2x minus 2e to the power x equals 15 and give our answers in exact form. So let's solve this. Rearranging gives us e to the power 2x minus 2e to the power x minus 15 equals 0. And therefore, we can factorize this as e to the power x minus 5 times e to the power x plus 3 equals 0. And therefore, either e to the power x equals 5 or e to the power x equals minus 3. However, we know that e to the power x is always greater than 0, and therefore e to the power x equals 5. And hence, taking the natural log of both sides gives us ln of e to the power x equals ln of 5. And so, x is equal to ln of 5. This brings us to the end of this session. If you have understood its contents, you should be able to describe and use the natural logarithm function. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.